My name is Ryan Paul, and for my senior project, I took a look at what scientists are working on at the Rutgers Institute of Marine and Coastal Sciences, and this is my presentation. So what they deal with there is they research our ocean. So here are just some facts about our ocean. Our ocean is about 140 million square miles, and it has an average depth of 12,200 feet. It covers about 70% of the Earth's surface. It holds 97% of the Earth's life and water, and it produces about half of the oxygen that we breathe. But we've only explored, as a species, we only explored about 5% of the ocean, so that leaves most of the ocean kind of unknown to us, not really knowing what's there. So what they do at the institution is they try to discover and they try to research things that we don't know about the ocean. Okay, so again, what they study more specifically at the Institute is just really anything about our oceans, anything about storm tracking, anything about marine life, so any type of impact that what we do as people has on marine life. Anything dealing with our oceans, and again, exploring the unknown 95% of the oceans that we haven't explored yet. Okay, and what they use to do their research are these things called gliders. They're also called underwater drones or autonomous underwater vehicles, or AUVs. What they are they're these small, kind of 8-foot long. I would say they kind of look like missiles with wings. What they do is they're kind of like submarines. They use small changes in their buoyancy and their weight to propel themselves through the water very slowly. They use very little energy, so they can stay out at the water for months at a time. They're much slower than other kind of automated drones, but that means they use less energy, so they can stay out in the water. They're very, very expensive. They cost about $150,000 in parts. That's not counting scientists, putting them together. And every time they go out and come back in, they use up about $15,000 worth of batteries. Actually Duracell batteries, and so it's a very big investment for Rutgers to kind of put these things out into the water. So why do they put them out in the water? What exactly do the gliders do? So what they do is they gather valuable information about the oceans, and they send all this data, all this information back to Rutgers. And what Rutgers does then is they put it into this thing they like to call the global portal, which is kind of, they upload this data to this service that kind of shares it with other scientists around the world. What that does is maybe other scientists can predict weather in one certain area thanks to, let's say if a glider is in, I don't know, South Korea, and there's a scientist in South Korea who wants to know what's going on with their water at a certain time, they can use Rutgers' drones to kind of figure that out. What the gliders can figure out about the water is, simply, the temperature, how warm the water is, how much light penetrates water at a certain depth, kind of how polluted the water is, how much energy currents possess, and what really happens underwater during hurricanes or during tropical storms or things like that, so we can get a better understanding of those types of things, of hurricanes and storms. So we come to something called the HMS Challenger mission, which is Rutgers' kind of big thing at the moment. It just started in this March of 2014, and what it is it's actually named for the Challenger Exposition back in 1872, which was an expedition started by the British, and it laid the foundation for oceanography back in the 19th century, and it was this military ship that was transformed into a scientific vessel, and it traveled about 70,000 miles over a 4-year period, and it circled the globe, and it made various discoveries. And now what Rutgers is trying to do is something similar, but much more high tech. What they're doing is they're taking 16 of these gliders, these autonomous unmanned vehicles, and they're flying them around the world simultaneously. So that's 80,000 miles around the world. All 5 oceans, all 5 ocean floors they're going to explore. And they kicked this off, like I said, back in March at the Oceanology International Conference in London. which is actually where the first HMS Challenger left off back in 1872. And so for the next 2 years, those 16 drones are going to circle the globe and collect information. And then on March 2016, which is going to be the 140th anniversary of the first HMS Challenger coming back, they're going to collect all the drones and kind of gather all their data together. And yeah, once all the gliders are again collected, they're going to use all the information. They're going to put all the information into their labs in New Brunswick and then send it around the world using that portal I was talking about earlier. Okay, so why is it important to have a Challenger mission? Why are scientists bothering doing this? So like I said earlier, the data gathered, especially with the Challenger mission, because it's such a worldwide thing, the data gathered there is going to help not only scientists in New Jersey, but people around the world do things like forecast weather, do things like predict storms, and really the main goal is to just understand more about our ocean and understand more about locally what exactly is going to happen if our oceans continue to rise the way they do, or what's going to happen if we don't change the way we deal with our environment, and we don't and we need to understand the environmental impacts we're having on our ocean. I put here in the PowerPoint timing. So basically, what we're worried about now is the oceans rising, but they're rising so quickly, and we're trying to understand why that's happening. So that's a big goal of our Challenger mission. So we have the risks with the Challenger mission. So thankfully, we're sending out robots. We're not sending out actual people. Back in 1872, when the first Challenger mission happened, it started off with a crew of about 244, and it ended up with 116 passengers left after a 4-year mission, thanks to things like death or desertion or illness. So it's not as bad as it was back then now, but we still have to deal with things like losing robots, which is not really as bad, but it's losing the robots or losing money or losing data that they gather. So 5 years ago, only about 10% of the gliders that scientists would send out would be able to complete their missions, and that's because of things like animal life, things like barnacles, things like sharks attacking them, things like that. Actually, when I went to the Institute myself, I interviewed one of the engineers who put the gliders together, and he showed me one of a shark bite that stopped the glider from working, and it almost cut the glider in half. It's this big plastic metal glider, but almost cut it in half. So I guess that's a common thing for them to be attacked by sharks. So when that happens, they're usually picked up prematurely out of the water so that they can't finish the mission, because they want to recover as much as the glider as they can. And due to the damages from sea life or rough waters or computer failures, rarely they have to be picked up. But mostly what happens is when the gliders can't complete the mission, it's due to human interference. And what I mean by that is possibly ships running them over, or them getting caught in fishing nets, or people coming across them and not knowing exactly what they are and interfering with the data they collect. So it was described to me that the first few days after a glider is sent out offshore is the most stressful time for scientists. And that's because there are so many ships and there are so many people or so many fishermen right on the shore going back and forth that it could interfere with the gliders. So I guess it was described that getting a glider offshore and not hitting any boats is the equivalent of like you trying to cross the New Jersey Parkway and not getting hit by cars, because there's so much traffic and there's so much danger, so much risk for the gliders at that time. But after a couple of days, once it gets out to open ocean, it's usually not as bad. They only have to worry about things like barnacles attaching to the wings of the glider, things like that. Okay, and really the overarching message or the overarching theme of why we're doing this is our future. So currently, technologies are not adequate to get us, the food we need, the water we need, and the energy that the human race needs. Right now, 1 in 8 people are starving, and 1 in 9 people lack clean water. And as population grows and we can't find really a remedy for the situation, things are only going to get worse. So what this whole program is about is trying to give scientists or give engineers just whatever they need to be equipped to deal with these situations. I have here in the next 100 years, cities like New York, Miami, and New Orleans Springs and other cities around the world are going to be completely underwater if the ocean keeps rising at the rate that it does. And can this research help us? I believe it can. It's really, if we don't understand the ocean, we don't understand why things are happening, we can't do anything to fix it. So this research that Rutgers is doing is monumentally important to everyone's future, not just people that live in cities and things like that, but really to
Call
everyone.
extension 6133. Gail
Thank you. And I have a
Alston, please call
5-minute
extension
video about
6133.
kind of harping on what I already said, but more in depth about what Rutgers is all about and what specifically the institution is all about.